Next, let's visualize the path the gradient takes as opposed to stochastic gradient, what I call the convergence paths. And as you'll see, the stochastic gradient oscillates a bit more, but gets you close to that optimal solution. So just like before in the black line, I'm showing the path of gradient, and you see that that path is very smooth and it does really nicely. In the red line, I'm showing you the path of stochastic gradient. You see that this is a noisier path. It does get us to the right solution, but one thing to note though is that it doesn't convergence stop like gradient does, it oscillates around the optimal. And this is going to be one of the practical issues that we're going to address when we talk about how to get stochastic gradient to work in practice. But it's a significant issue. Another view of stochastic gradient oscillating around the optimum can be viewed in this plot, the one we've been using for quite a while. And you see that gradient is smoothly making progress, but stochastic gradient has this noisy curve as it makes progress, and as it converges, it's oscillating around the optimum. Let's summarize. Gradient ascent looks for the direction of greatest improvement, the steepest ascent direction, and does that by summing over all possible data points. Stochastic gradient, on the other hand, tries to find some direction which usually makes progress. So, for example, by picking one data point to estimate the gradient. And on average, it makes a ton of progress. And because of that, it tends to converge much faster, but it's noisier at the optimum. So even in that simple example we've been using today, it's over 100 times faster than gradient to converge. It's much, much faster to converge. But it gets noisy at the end.